Good morning, students. Today we are starting with threads. A thread is a part of a process. A thread is a part of a program. So it is nothing but an execution unit of the CPU processor. All threads of the same process share the same address space. So whatever the memory space is allocated to the process, that memory space is being shared by its all threads. So all threads have separate stack and individual thread ID. Just similar to the process, each and every thread has its own unique ID and its own stack to maintain the local variables, local data. Thread is a lightweight process because the context switching between threads is inexpensive in terms of memory and resources. As threads share the memory space of the process, whatever resources are allocated to the process, all those resources are being shared by its all threads. So the context switching between threads is inexpensive. For an example, if we consider a Word doc file, while editing a Word doc file, one of the thread is created for that process. The job of that thread is to save the content after some duration to the secondary storage. So even if user doesn't save those content, user doesn't press Ctrl S and electricity goes off, once the user starts again the system and will open the same doc file, he or she can see the auto saved content file. The application will ask user whether he or she wants to view the auto saved content file or the original file. So the job of that thread is to save the content to the secondary storage. Multi-threading concept. Ability of an operating system to support multiple concurrent paths of execution within a single process means in a single process n number of threads can be created. If an operating system supports for the multiple threads in a process, so n number of threads can be created in a process. Let's assume this is a process and n number of threads can be created for that process. Let's take an example. Let's assume that this is the Excel sheet. In the Excel sheet, we are trying to maintain the record of 100 students having the marks of maths, chemistry and physics. In the fourth column, we are trying to find the sum of all these three subjects, and in the last column, we are trying to find an average of these three subjects. Let's assume that the formulae are applied in all these rows before making an entry of these marks. When I put marks in any one of the column, automatically the two threads are activated and these two threads are executed at the background for application spreadsheet, and these threads would be scheduled and executed. The sum you can see once I put 10 in the column A, the sum you can see here 10, and even the average of these three marks you can see in the last column. Similarly, if I put here again the 10 and the second column, automatically this thread would be executed and it will perform an addition of these two numbers. So accordingly, n number of threads can be created on one application. So one process can have n number of threads. It is also described as the interleaved execution of the threads. Two threads execution can be interleaved. Here two threads are created, one to perform summation of all the numbers and one to perform an average of these numbers. So this execution can be interleaved. In the diagram, we can see here one process has only single thread, whereas the another process has multiple threads. For each and every process, the main thread is created and that main thread shares registers, stack, code, data and files. If it is a multi-threaded process, in that case, for each and every thread, it has its own unique ID, its own stack and its own registers. Whereas all these threads will share the code of the process, the data of the process and the files of the process. Here we can see a number of examples for the threads and processes. If we look at this diagram, in this case an operating system supports for one process with the one thread. Means you can execute a single process at a time with the single thread, which we call it as a main thread to be created for that process. Whereas in this case we can see that multiple processes we can execute, we can schedule, but for each and every process only main thread can be created. It means that process cannot have multiple threads. Whereas in this case we can see one process can support for multiple threads. Nowadays, whatever operating systems we are using, like Windows, Linux, Mac OS, all these operating systems are supporting for multiple processes with multiple threads. So example for each and every case. For the first case, that is the one process with the one thread, the example is MS-DOS, Microsoft DOS operating system. It can execute only single process at a time. The another example is Unix, that Unix supports for multiple user processes but only supports one thread per process. And the third case, Java runtime environment supports only one process with multiple threads. And in the last case, nowadays whatever operating systems we are using, Windows, Solaris, Linux, Mac, all these kinds of operating systems supports multiple threads with multiple processes. Then what is the difference between threads and processes? A process is a program in execution. Whatever the program we are running, whatever an application we are running, for each and every program, for each and every application, one process is being created by an operating system. A thread is a part of that process. A process has its own process ID which is assigned by an operating system. Similarly, a thread has its own unique thread ID. Every process has its own memory space which is being assigned by an operating system, whereas threads use the memory of the process they belong to. Inter-process communication is slow as processes have different memory address space. Whereas inter-thread communication for the threads within the same process is fast as they are sharing the same address space. It will be fast as possible as the context switching is more expensive in terms of memory and resources, whereas in case of threads the context switching is less expensive in terms of memory and resources, majorly because threads of the same process share the same memory space. The thread operations include thread creation, termination, synchronization, scheduling, and many more. Thread creation, termination, synchronization can be done at the user level as well as at the kernel level. All threads within a process share the same address space. What exactly they do share of the process? All the process instructions, data which is being used by the process, all that data can be shared by its threads. Open files, signals, current working directory, user and group ID. Whereas each thread has its unique ID, its own set of registers, its own stack to store the local variables data as well as return addresses and the priority. Similar to the process, each and every thread has its own local variables. To maintain this data, it has its own stack. Just same as the process control block, the thread control block is being maintained for the data for each and every thread. N number of processes can have n number of threads and these threads can have the priority. There are two types of threads, kernel level threads and the user level threads. In the diagram you can see the kernel level thread can be executed in the kernel space, whereas user level threads can be executed in the user space. As we know, the primary memory is divided into two different spaces, kernel space and the user space. Kernel space where the all operating system functions are being executed, whereas in the user space all user programs are being executed. The kernel level thread is created by the operating system, whereas the user level threads are created by the user. User level threads are implemented by users and the kernel is not aware of the existence of these threads. Kernel handles them as if they were single-threaded process. As kernel does not aware of all these user level threads, operating system understands them as a single-threaded process. So all these threads cannot be scheduled by an operating system. All these threads can be scheduled by the user by using the user level library utilities. User level threads are small and much faster than the kernel level threads. They are represented by a program counter, stack, registers and a small process control block. This small process control block we used to call it as a thread control block. Also, there is no kernel involvement in synchronization of the user level threads as operating system does not aware of the existence of user level threads. The synchronization and scheduling of all these user level threads can be done by the user by using user level library. So user level threads are managed entirely by the user level library. One of the user level library is POSIX, that is Portable Operating System for Interface for Unix like system, that is POSIX thread library. Advantages of user level threads. User level threads are easier and faster to create than kernel level threads as these all thread being created in the user space. They can also be more easily managed. User level threads can be run on any kind of operating system as kernel is not involved to manage these threads. There are no kernel mode privileges required for thread switching in user level threads. Disadvantages of user level threads. Multi-threaded applications in user level threads cannot use multi-processing to their advantages. For an example, even if system has n number of processors, user level threads cannot be scheduled on these multiple processors and we cannot execute these user level threads simultaneously. This is the main drawback of user level threads. Entire process is blocked if one user level thread performs blocking operation. For an example, if one of the thread is executing IO operation, the complete process is being blocked. We cannot schedule the other threads from the same process. Kernel level threads are handled by an operating system directly and the thread management is done by the kernel. Context information for the process as well as the process threads is all managed by the kernel. It means all kernel level thread synchronization scheduling is being done by the operating system or the kernel. Because of this, kernel level threads are slower than the user level threads. So advantages of kernel level threads are multiple threads of the same process can be scheduled on different processors in kernel level threads. Kernel level routines can also be multi-threaded. If a kernel level thread is blocked, another thread of the same process can be scheduled by the kernel. As all these threads are being managed by an operating system on multiple processors, these kernel level threads can be scheduled by an operating system. Disadvantages of kernel level threads are a mode switch to kernel mode is required to transfer the control from one thread to another in the same process. The mode switch is required that we have seen. Kernel level threads are slower to create as well as manage as compared to the user level threads. The next programming part will be covered by Professor Banchor sir. How to create a thread, how to terminate a thread, how to attach a thread with the main thread. All these concepts will be covered in the programming part by Professor Banchor sir. Thank you.